We talked about this when we were working with functions, right? And tables, you have an input, you plug that into the function, you get an output. So the relationship between them is the proportion. Like, how are they changing? Are they all being multiplied by 2? Are they all being divided? That's the relationship that we're talking about. Okay? Sometimes we can use proportional relationships to compare prices, which is our first example. It's talking about tomato prices. Okay, and it says in our books, you can get 2 pounds for $3, 4 pounds for $6, or 6 pounds for $9. So we're going to determine if the relationship is proportional. Okay, so are they the same? If I take 2 over 3, right, 2 is my first number, 2 over 3, that can't be reduced. It can't be simplified. It's 2/3. If I take 4 over 6 from the second piece of information, that can be reduced. It can be simplified. And when I divide them both by 2, I get 2/3. Last one, 6 pounds for $9, can be reduced by 3, which will give me 2/3 again. So this is proportional. The difference between them was all the same. Okay? Pizza slices. Let's say 1 slice for $2, 2 slices for $3, 4 slices for $5. Is this one proportional? It's not, because our numbers are not going to be the same. 1/2 is what we start with, then 2/3, then 4/5. Okay, so the relationship is not proportional. No is all you need to put. If you look in your books on page 93, you'll see a graph. You can also determine whether things are proportional by looking at a graph. So if your book isn't handy, please open it up so that you know what I'm talking about. Example 3 is talking about jewelry. It says Jenna earns $12 per hour making bracelets. She uses the function E equals 12H to track her earnings. So E is what she makes. H is the number of hours it takes. Make an input-output table and graph your results. So E equals 12H. That was given to us in the problem. Okay? We have to graph it and make a table. So H is the number that's going to be changing. So H goes first. E is the number she's earning, right? That's like the cost. So that's going to be the output, the one it changes. You make more the more you work, usually. Okay? So what makes sense for numbers? So we weren't given any numbers for H. So think about the story. A girl named Jenna makes jewelry. What type of numbers should we put down for hours? Would it make sense to pick -2? No, because you can't work -2 hours.
You put like how many hours she works, so like
What do you think?
2 hours.
2. 2 is a great one. So we should have at least 4. 4 numbers that we're putting in. Do we want to put in 40? Why? Yes or no?
No,
Why, Jackson?
too much.
Yeah, that's going to be a really big number, right? Ideally, when you grow up, you do want a 40-hour-a-week job. But for our math in 8th grade, we want to use numbers that we're comfortable with. Does that make sense? Grace, can you give me another number? Welcome back, by the way.
3.
3. Jacob, can you give me another number?
6.
Great. Sophia?
4.
4. Okay? And maybe we'll put 1. Maybe she has a lazy day. She's not feeling good. She's only going to work 1 hour. Okay? Maybe it's a part-time job. Anyway, now we've made our inputs. So we need to do our outputs. All of these we're going to be multiplying by 12. That's the math. That's the relationship. That's the proportional relationship. So that's why we didn't want 36, right? That's why we chose small numbers. So 2 times 12 is my first one, which is
24.
24. Then I have 3 times 12,
38.
36. 6 times 12,
72.
4 times 12,
48.
and then 1 times 12. Okay, so now I've got my table. Table is done. Input, output. Sometimes, in some situations, you may have to pick the numbers. So it's important that you understand the question so that you pick good numbers. That was the only hard thing about the input-output table, is picking the numbers, what makes sense. Now we need to graph them. So, try and scoot this over a bit. I've got to make a graph. It doesn't need to be a true coordinate plane because, again, I don't have any negatives, right? I'm not going to lose money, and I'm not working negative hours. So I only need positives. And if I sit, usually time is on the bottom, whatever you're talking about. And in this case, we're talking about hours, so I'm just going to put hours. Oh, sorry, thanks. And then along the side, we're talking about earnings. So I'm going to put earnings along the side. So if I work 0 hours, I make 0 monies, right? So I start at 0. And then because we picked small hours, it makes sense to count by ones along the bottom. So I'm just on every graph, just going to do 1, 1, 2, 3, 4, 5. I think my highest was 6. So I'm going to go to 7. And then going up, I'm going to count by 12s because that was our proportional relationship. It was times 12. So that means my first tick mark is 12. My second one will be 24, 36, 48, 60, 72, and then what, 80? Thank you. 84. If I just count by 12s, even though I'm not going to need all those, right, because those weren't all the numbers we picked. Okay, so now I'm going to graph it. So my first one was 2 and 24. So over 2 and then up to 24, I'm going to put a dot. My second one was 3 and 36. So over to 3, up to 36, and I'm going to put a dot. Next was 6 over to 6, up to 30 or 72, all the way up. There we go. Put a dot. 4 and 48. Put a dot where those meet. And then lastly, 1 and 12. Going to connect those dots to finish my graph. This will continue on, right? Because of what we're talking about, it's not just going to stop. If she works more hours, she's going to make more money. So I'm going to put an arrow on the end. We can use tables to determine whether we have a proportional relationship, right? 2 over 24 equals 1/12. 3 over 36 equals 1/12. 6 out of 72 reduces to 1/12. All of these numbers reduce to 1/12. So if they give you a table and ask you whether it's a proportional relationship, this is what you're checking. Does anybody have a question on that? So this is yes. Yes, all of the fractions are the same. Also in a graph, you can look at a graph. If it makes a straight line, like ours did, the proportional relationship is the same. Okay, it made a straight line. So if they show you a graph and the line is wavy up and down, not proportional, right? That means there was a change. It didn't continue to climb at the same rate. We want the fraction to be the same. So we went over 3 different examples. Some were words, some included money. All included either reducing or multiplying, so that you'll be able to do the assignment, which is to find out whether the numbers are proportional. Question?
If we have homework for the example.
If we have homework.
If we have homework.
On your homework, yes.
For homework, the example we just did, are we gonna do the graph on there as well? Or?
I think for one of them, they do ask you to make a graph. Just one. Okay? You guys ready for the homework? Great. On page 94, there are tables, some money information, and one graph problem.
Wait, what page? 94.
On page 94, you're going to be doing numbers 5 through 13 all.
No, you can